Hello, everyone. My name is Grant Stewart, and I have worked for Marigold Library System every summer since 2016. And after the 2019 summer, I was fortunate enough to be hired on as their marketing and outreach specialist. I've done this program over 50 times, and I have a system that works for me, and it can be completely adapted to any program that you want to put on. It can be lengthened, it can be shortened fairly easily, and it can be changed to be only online or only offline. We'll discuss that a little bit later in the presentation. So let's get started. First things first, why teach coding to kids? Well, libraries are strong proponents of both early literacy and digital literacy, and tech literacy is becoming more and more important. Children as young as 3 can be taught some of the basic principles of coding and are, in fact, learning some of the concepts already in their regular interactions with others, such as learning from mistakes, taking turns, and sharing. Coding is a creative process that involves problem solving, critical thinking, and collaboration, all of which are important skills in life. Concepts such as sequencing, which is putting things in the proper order to have them take place, like baking, and if-then, which is understanding that if one thing is done, then something else will follow. These are not concepts that are unique to coding in any way, shape, or form. Coding also gives children a greater understanding of computers in this digital age. Computers are involved in all areas of our life, and it's important to teach children this aspect of the world around them. Coding knowledge is becoming one of the most sought-after skills in the job market. Some of the career options for those with coding skills include web design, gaming development, software development, artificial intelligence, robotics engineering, and data science. And I mean, so many more than that. But the soft skills, such as problem solving and collaboration that are learned through coding, serve children in other areas of life as well. First up are some offline worksheets and activities that you can do without a computer. They're just printed out. First are the binary worksheets. The bracelet activity you can see in the top there works really well to show how different it is to make letters on the computer than it is in plain English. This also shows that binary is a different way to express the same concepts that are in English. It creates a connection between what the children already speak and what computers use to communicate. The binary bracelets are really easy. You pick the first letter of the child's name. So my first letter is G, and find it on the list here. So right there. I hope you can see my cursor. And so then you find it on the list, then color in the corresponding squares at the bottom here. So these squares down here. So for G, you color in this square, color in these 2 squares, and then color in this square. And then that would make the binary letter G. And then at the end, you get a bracelet to take home for the kids. Now with this, you can do it with beads, you can do it with anything really. You don't have to use the paper here. It could be really anything, as long as you have 2 different colors, and that'll do it. Next is this binary puzzle. Now the binary puzzle is a little bit difficult at the start, but after the kids kind of figure it out, it gets pretty easy. So you can see this little line up here. The grid is in half. So on the left side of the grid, you have 8, 4, 2, 1 at the top. You have to imagine it. And then it repeats on the right-hand side. So 8, 4, 2, 1. So when it says 1, then 8, you color in the 1 square, and then on the other side, the 8 square. So for 3, then 12, you color in the 2 square and the 1 square. And then on the other side, you color in the 8 square and the 4 square to make 3 and 12. So it's better if you can actually look at it and color it, and then it kind of makes sense with that. And then after you do the puzzle, it creates a full picture, and that's fun for the kids. Next up is Robot Turtles. This is another fun offline activity that helps kids become more interested in coding. The instructor sets up obstacles for the players and moves their turtles around the board exactly as the children say. That's important. The children have a set of cards with instructions for the turtle. The instructor follows the instructions to the letter, and if they don't get the jewel, then the next person goes. This is a good way to show and teach how literal computers are, and to code, you have to instruct the computer exactly as you want them. If you have them in a different order or a weird sequence, the computer won't let you do that. So you have to have the order you want. Some other offline activities, these are great to do as well. Sequencing activities are ways to, again, get kids to understand the literal nature of a computer. It's important to stress that, and that you need to put your instructions in the right order or they will not work the way they were intended. By dramatizing a non-coding process, you're showing that even though the name for the task may be simple, like taking out the garbage, it takes more steps. You need to get the garbage out of the can, put a new bag in, bring the garbage outside to the dumpster, put the garbage can away. So it takes more than just what the title is. Computer Science Unplugged is also a fantastic resource to use. It puts a lot of different activities similar to the ones we mentioned and puts them all into one easy to find place. There's the website right there. Next up are some online resources we can use to help the kids learn how to code. So this amazing website is called code.org/learn. It has so many free coding games that use a basic coding language called Scratch. Scratch uses pieces of already built code that snap together into readable code for the games. Because this website has so many games that are themed, like Star Wars, Minecraft, The Grinch, Moana, and many more, it's very familiar and inviting for kids to play. Another important factor is that it recommends what age would be best with each game labeled by grade level. This makes it easy to change what game a child is playing if it's too advanced or too simple for them. Now I'm going to take you to the site to show a game in action and what Scratch looks like. So here is our website. So I am going to show you the Star Wars one first. So you just click and you see there it says grades 2+, blocks, JavaScript. Now it says JavaScript, but it's really just the blocks. So you just click there and then you click start. And you can choose blocks or JavaScript. The blocks is what we're going to use for our purposes, and it'll load up here. So it immediately opens up a video. You don't have to watch this video. It's got the notes too. It's got the transcript with the images, but it really doesn't. It's just kind of marketing. You don't have to watch it at all. So Ray says, we need that scrap metal, BB-8, can you get it? So you click OK. And so what it's asking you to do is add a second move right command to your code. So you close that, and so you can see that you get a bunch of different blocks, and you can see this is in a grid pattern. So if you were to press run now, it would just move one to the right. So you reset it, you add a second move right command, and you can see how it highlights on the top one there, and that means it'll just snap into place for it. And then he gets the scrap metal. So with this, you can show the code that you've done, and this is what I mean by, so it's the same, it's just formatted a bit differently. So that's in JavaScript, but it works the same way. You press continue. So similar thing, you've got to move right and then down. So if I were to move down immediately, it would just hit this block here, right? So you move right twice. You see again how they snap right into place. And then you move down twice and you watch him do it. And now these do get, obviously these are pretty easy. They get more complicated, so we'll skip to number 8 here. So this one is your mapping. So these are when you click the up arrow as opposed to when run. So when you click the up arrow, you can have the droid move up. So they're colored differently. So the run button's always orange. So the when run blocks are always orange as well. So that's how they're done. And if it's a when, so when something happens, that'll always be green. So we will just click these into place quickly here. And those are attached. Now, obviously you can't see my, they're all mapped to my arrow keys on my keyboard. But you can also click these. So if you want R2, so now we've mapped them. So clicking on the arrows will then move R2D2. And you can see on the blocks here how it highlights the one that you're using. So that's helpful. And then it can get quite complicated. So this one's got sounds. So if we go to number 13 here, this is one where it has a little bit of math, a little bit of like, oh, they're multiplying. That's good to understand. So when you run, it's going to add a mouse droid to the screen, and it's going to play the R2D2 sound. I have it muted, but what you want to do here is when get mouse droid, because it says, can you make sure mouse droids appear every time R2 gets one mouse droid? So get 20 mouse droids. So when you get a mouse droid, you want to add 2 mouse droids. And then you press, and this one already has the buttons mapped. You don't have to map the buttons again. So you press run, and I'm using my arrow keys just to make it go a little bit faster. And you can see as I get each mouse droid, 2 more appear. And eventually we will get to 20. And you can see how quickly the screen's full of them. So those are the more complicated puzzles in this. So, and this one the purple colors change the droid you have, so you can change it to C3PO if you'd like, and the map that you're on. So Endor blank map. It's just fun to like customize what you're doing. That's good for a little bit of creativity in there. So that's what everyone, so I'll close this one. So I'll open up the Minecraft one. You can see it's exactly the same. It doesn't matter which one you click. They're all just slightly different themes. So again, another video. You can select a character, and then okay, we're having, so this sometimes happens with code.org. There it goes. It takes a second, so you have to remind the kids to be patient. So same thing, move forward twice, right? It's exactly the same. But yeah, so that is code.org. As you can see, there are so many different games, like Moana's the same. I recommend doing ones that have this logo. They're normally good. Because some of them are like not what they say they are. Like you want to keep them on the Disney ones and the Minecraft ones and the ones like that. So we'll go back to the PowerPoint. So that is code.org. It's a staple of what I use. It's really great. It says an hour. It normally takes the kids 20 to 30 minutes to do that. So fully. Next up is Code Combat. So now this game is a great game for kids who have played games on code.org and need some challenge, but they're not super advanced yet. It's completely free and teaches actual coding languages that professionals use. It's a great step up from the Scratch games because it isn't too advanced that the kids will become disinterested or frustrated, but it's more advanced than the code.org games. So we'll go to that one too. I've got it loaded up here. So you just click play, and you don't need a class code or anything like that. So you just click play again. So we'll go to this one. So this, you can like pick a character and have them equipped with armor. So it's a little bit more game than the other one. So you can play that. This one also comes in many different languages, which was good because it has French. So I had a child in Banff who only spoke French, And so we got him onto Code Combat because it was also in French. So this one you have to actually type, and it's got the different things. So he's already moving right, so now you want him to move down. So you have to type in. So you can click there, and then so this is, you know, slightly different and a little more advanced because you need to be able to type. It's really good for the intermediate audience. It's great for that. So it's got Python. I think it's got other different coding languages, but I would stick with Python with this because it's pretty easy. So that's Code Combat. It's got, you know, you saw these are all levels. So it's got many different levels. Really great to keep the kids occupied throughout your lesson. So that's a good one. And that teaches real coding languages, which is important. Next up is Codable. So where Code Combat went a little more advanced than Code.org, this is a little less advanced than most of the games on Code.org. So this one you can also find on Code.org. Same with Code Combat, but it's pre-reader to grade 5. So it's good for that because I've had young kids that can't read yet, so that's really good for them to be able to also play with the kids, and they don't have to read anything. So I'll just load this up quickly. Teaming up, and you can see the big, huge cursor. It's really friendly for kids. It's very colorful. It plays a very obnoxious sound that's going to play in my ear in a second. Yep, there it is. So you click on there. There's a little video. This one, you can't skip it. I've tried. So it's got, like, you know, the fun, cute, furry characters. Very eye-catching and colorful. And I do recommend muting the computers if you're doing a program with a bunch of children with this one, because it's very loud and you have, you know, 10 different kids playing the same song at different times. It gets a bit chaotic. So I would recommend having the computers muted. So yeah, see, it's that easy. You just drag the arrow key or the arrow icon into the thing, and that. So very pre-reader. All they need to do is use a mouse. You know, big hands. It's very kid friendly, which is great. That's what we want. So that's a good one to show and to have. If they're like, I always start with code.org, and if someone's like the other coding games, and if someone's struggling, then I put them on this one, and they have just as much fun. Next up. So it's great. That one's a really good one to have in your back pocket. And because you don't want the kids to be frustrated by code.org, that's the last thing you need. So this one's less frustrating. So this is Code Academy. This is a great resource for teaching coding. The basic courses are completely free, but you do need an email account to sign on, and it's a bit intrusive with how it asks you to add a credit card and stuff. You can just hit back out of it, but it's a bit intrusive with that. So this one would definitely be for older kids, or more advanced kids anyway. It's a great resource for adults too, as it gives lessons on web design and coding languages like HTML and Java. It's actual lessons. This is not a great site for younger kids. It's not a game, so they might become disinterested or frustrated by the instructions. But if you have a kid that has played code.org games and Code Combat, this is a great resource to have. I will quickly show it to you. So this is the home screen. I'll just log in. And so this is what it looks like when you first log in. It has a big like put your credit card details in, and then there's a back button in the top left-hand corner. So I'll just show you, like, these are courses that I've done. So we'll show you this is the HTML one. So we'll just, so this one, it'll give you instructions on the left-hand side, and you read them, and then you input the code into the right-hand side, so, or into the middle here, and then it'll show up on the right-hand side. So it's, you know, very lesson, but I mean, it's interesting in the way that it's an actual lesson. So it'll be good for people that really want to learn coding. Like, you know, you have some kids that really want to learn actual coding, so this is a good website for them. Yeah, so that's Code Academy. Another good one to have if they're too advanced for Code Combat and Code.org. And then you're like, oh, well, you can play this one. Really good to have. So now on to the fun part, the gadgets. This is the part of the program that usually most resonates with the kids, and I personally have the most fun with. So first up is Code-a-Pillar. As you can see, this is clearly meant for very young kids. It's made by Fisher-Price, very durable and resistant to impacts. It's a plastic toy. It uses sections of its body with the arrows on it to go in the direction indicated by the arrow in the order the arrows are placed. Now, again, this is teaching the importance of sequence and telling the computer exactly what you want it to do in that specific order. It comes with green and red plates that you can use to have a starting place and where you want it to go, so you can make kind of an obstacle course feel with it. There's a Code-a-Pillar app. Now, the Code-a-Pillar app is a game on iOS devices that is themed with the Code-a-Pillar. It's a simple coding game that is pre-reader, so it's good for kids that younger children. It's a great resource for children that are already really like the Code-a-Pillar and want more with it. So, but it's completely separate from the actual product. So, but it also makes fun, bright noises, and I used it in the office one day and it was a bit obnoxious, but yeah, it's a good one for little kids and it's very durable, so they can't really break it, which is very important. Now onto the Sphero. This is the best coding gadget you can buy, the Sphero SPRK Plus. The Sphero is a small ball that uses code in order to move, but it can also be used like a normal remote control device. The Sphero is fun and interesting to look at. The Sphero also uses Scratch coding language, so it's easy to transition from the games on code.org to real-world interaction. It's a nice connection there. It shows the kids that code can have real-life applications and impacts in the real world. The Sphero app for Android or iOS is required in order to use the Sphero, because that's how you put the game, like the code in, and use it as a remote control. There's also ones that are themed with Star Wars. They might have discontinued them, but I know there was like an R2-D2 one and a BB-8 one, so that's, it's good to have things that will capture the children's attention. It lights up. You can see kind of the lights in there. It lights up, and you can change the color of the light. You can change anything it does. It's really the best gadget you can get. Next up are little bits. So they're to show children how power and electricity works. This also helps with coding because everything happens in an order similar to coding. It's also a great way to get the basics of how electricity and electronics work before jumping into a computer and learning how to code. Little Bits also has a coding set where you can create games with Little Bits and code. That uses JavaScript and gives real experience. It's for the more advanced kids, definitely, because that uses actual coding languages. yeah, so that's little bits. Next up, Lego Mindstorms. So this is a robot system that is built using Lego that users can program themselves. Lego Mindstorms uses its own language that Lego has built specifically for beginners. This is a great way to meld the lessons learned in little bits, like the building aspect, with the coding they learned from Sphero to create a robot that they can tell what to do and configure in many different ways. You can see there's a dog and like a robot and like a crane arm, things like that. It's really customizable and cool. But again, a little more advanced. Like they need to know how to use electronics and stuff. It's for beginners in the sense that they know how to interact with it a little bit. So what my programs normally look like. To start, I generally use the offline paper activities that teach binary and how computers send information using that. I first tell them to choose a game on code.org to load while we complete the worksheets. This gives me time because sometimes I'm in rural locations where the internet doesn't like to cooperate. So it's important to have the games loading during this. I explain the worksheets and I help out whenever they're needed. After the worksheets, and the worksheets normally take about 10 to 15 minutes, but I've had it take as much as 20. We move to the computer game that has then loaded up. The kids read the instructions and then play the game. My sessions are an hour long, so this takes place from about the 15-minute mark to about the 40-minute mark. That's kind of where we're at. After 40 minutes, I take the kids off the computers and have them play with one of the gadgets. The Sphero, again, is especially good for this because it uses the same coding style that's used in the computer games. As a group, we build a small obstacle course that the kids will put the Sphero through. I line them up, and each kid gets a chance using the coding to get the Sphero through the obstacle course. Because you can program the Sphero to move for 2 seconds at this speed. So a kid will have to do it, and then it'll go way too far. So then go to the next kid, and they're like, oh, that went too far, so let's shorten the time or the speed, and then it'll go as far as we'd like. So I've gone through the line 2 or 3 times before it finally gets figured out and the process is done. This is a great teamwork activity. Since the kids are all discussing and they're building on each other's code, it's really cool to watch them figure it out and do the code. After we play with the Sphero, I tell them that it's time to go, and I hope they had fun. Some kids want to continue with the Sphero, so if the group has been good, I generally let them continue playing with the Sphero as I pack up. That's up to you, really, because I have to pack up a bunch of laptops, so that can take me another 10 minutes. So I normally let them play with the Sphero as I'm doing that. Great opportunity also to ask the kids what they've learned during the program, have that kind of debriefing that explains, like, what did you learn? Did you have fun? Stuff like that. So to keep kids engaged with this, it's essential that you switch activities regularly. I find this is because as the advanced kids start to get done with one portion, you need to get them onto the next activity fairly quickly because they do get bored very quickly. Now you can set up this program in many ways. I do one-off programs because I only go to a specific library one or 2 times during the summer. But if this were to be a weekly program, you could extend the offline activities for a longer period and give the kids more familiarity with how coding works. The online activity could also be stretched over several classes so that everyone is on Code Academy and able to use Scratch effectively and efficiently, and they're learning more advanced coding. Then final day, gadget day, that'd be fun. The kids all use the Sphero and I'll use the little bits and stuff like that. So that's putting the skills that they've learned on the computer into actual practice offline. So some common issues I faced when organizing the coding program. First and foremost, more kids than computers. For this, I normally move everyone to the computer portion right away and rotate them off while the person is not currently on the computer. And then the person that's rotated off will be doing the binary worksheets. Or if everyone has done those, potentially with the gadgets, I'll rotate them off with that. Kids acting out is another common problem I faced. I generally give them a warning, and if they're still acting up, I take them off the computer or out of the line for the Sphero for like 5 minutes. And if they still continue, I take them off for the remainder of the program. Next, if someone is too advanced for the normal program, for like Code.org and Code Combat, I immediately move them to Code Academy and have them work on that. If they're not advanced enough, I immediately move them to Codable and they work on that. If I've had this problem very often, no internet. I have them do the worksheets, and then we build a very elaborate obstacle course for the Sphero. So you can extend the worksheet activity and then extend the gadget activity. So you don't necessarily need to do it online. And I mean, obviously now, that's more info for the future, but yeah, it's very easy to configure. So now if you want to do an online activity, you could definitely just do Code.org, Code Combat, Code Academy, and you could have them check in with like what level they're on each or things like that with online stuff because of current events. So that is that. Are there any questions that people have that I can definitely, hopefully answer?
Hi, everybody. Please feel free to use that question chat box. Grant, we had a question for the websites that you were demonstrating there. Are they all free?
Yes, they are all free. Code Academy has, I'll go to it, it has pro aspects. Like you can see, it says practice pro, apply pro, but that's all optional. You don't need to do the pro stuff. So like with the courses, with the introduction HTML, you can see like these are the different lessons. So you can do the interactive lesson. The quiz is pro, but you don't really need to do the quiz, So it is free. There are pro aspects, but they're completely optional and, in my opinion, unnecessary.
Okay. Somebody else is wondering, Grant, how much is the Sphero?
The Sphero is about $120. That was what it was when I first looked on Best Buy. And there's different, yeah, 130. So it's gone down a bit. The SPRK Plus is a bit different, but yeah. So I recommend the SPRK Plus, definitely. That you can see through it, and you can see the electronics working. But yeah, $120 to $150 in there.
And someone is wondering what ages is Lego Mindstorm recommended for?
I would say probably 10 plus. You could maybe get as young as 8, but definitely a little older than other things. Yeah.
And do you recommend any books to go along with your programs?
I personally haven't done books with it, but I know there are some really good coding books out there. I can't tell you any off the top of my head here, but there are ones that specifically go with the Code-a-Pillar. I know that, and there are good coding books out there.
What size of a class are you most comfortable with?
12 is my max because of how many computers I have when I go to do these programs. I have done more, you could probably get away with up to 20, I would say. Well, if you have more than, as many kids as you have computers, plus like a few more, if you need to switch off and stuff like that.
When you create your programs, like, do you limit a program to certain age groups?
I do. I normally, with this one, I do 8 to 12, but I've had kids as young as 4 that, their siblings are at it and they want to play. So, you can do any age, but I normally do 8 to 12.
Okay. Okay, so you said you can do basically as many kids or a few more as you have computers, but what would you feel would be the ideal number? Like, what is the easiest size group?
I mean, 12 has been perfect for me. If you do too many, it gets hectic, pretty quickly, especially if you don't have the computers muted, and it's hard to answer all the kids' questions. So yeah, my ideal is 12 kids, but it's possible to do more or less.
Another question about the Sphero. You've mentioned something about an app that you use with the Sphero?
Mm-hmm. Right.
Can you just is it something that you just get for free at the App Store, or?
Yeah, it's just a free app that you can download. There's two. There's the Sphero normal, and then there's the Sphero education one. The Sphero education one is the coding one, and the Sphero normal, it's just Sphero. That's the remote control one. But the education one can also be used as the remote control. So yeah, they're completely free on the App Store. You can find them really easily. You just look up Sphero on the App Store. And then it connects to the Sphero through Bluetooth, so you need your Bluetooth on. But
are there any other French coding programs?
I haven't specifically looked. I don't speak that much French, so it's difficult to research. But I know Code Combat does for sure, and that was the quick solution I got in Banff. Other than that, I'm not 100% sure. I think the code.org games can be French, but I think you need to download them for offline to do French. Because I know when you download the games offline here, because if you go to code.org, you can, if you go back to the Star Wars one, I think, yeah, languages, English. So these would work too. There's French. So if you click start, I think, yeah, download the offline version. That's what I did. Yeah, download in, as many languages as you want. So yeah, it's possible to do those in French. I haven't personally tried because in that one, Code.org was being a bit unhelpful. It was not loading well, so we had to use Code Combat. But yeah.
Someone wondering, do you use Chromebooks for the kids to do the online coding?
No, they're Dell Windows laptops. You could use a Chromebook, definitely, as long you just need the internet. So yeah, you could definitely use a Chromebook. I haven't, but you definitely could.
Do you have?
I mean, really, a lot of the Oh, go ahead.
No, sorry.
A lot of the games are also apps on the App Store, so you could use phones too if you really wanted to.
Do you have suggestions for implementing successful coding programs during these times?
Yeah, I haven't tried yet, but it's definitely more difficult because you don't have the gadget and the paper. You can still send the paper activity, I guess, just have the parent print it out. But I mean, like I said, you could definitely do the coding program and do it kind of like a book club, like have everyone get to level 5. And then the next lesson you can do, or, stuff like that, like have check-ins with things, or do it over Zoom. That could work. The only issue I could see there is bandwidth, where the game might not load. So, I mean, it depends on how you want to configure it. But there's definitely options for you. Yeah. I mean, if you want more suggestions with that, you can definitely email me, and I could probably help out with that.
More about the Sphero. So you said you can connect it with Bluetooth. Can you use that with an iPad, or does it just have to be a phone?
No, you can use it with any iOS or Android device. So yeah, any tablet, yeah. Not with computers, but with any phone or tablet.
Do you ever have participants bring their own computers?
No, because I provide computers. I haven't had that, but I mean, there's no inherent need to provide a computer. Like, as long as they can access the internet and go to the websites, I don't see an issue with bringing their own computers.
For the Sphero obstacle course, what kind of things do you use to create the obstacle course? Like, do you have ramps and things, or?
Well, you could definitely bring. We use the tables and the chairs. There is what I've mostly used, just what we have available. But you could definitely, set up cardboard ramps or things like that. Because I'm traveling so often, I don't like to bring too many things. So we use, the one library had couches. We use their couch cushions. Whatever you're comfortable with in your library. But if you're doing it like as a weekly thing, you could definitely make obstacle course like things and have them permanently. I do always ask the librarian if it's okay to use the couch. I don't just do it. Just to clarify.
Excellent. Okay, so that's all the questions so far. I'll just give it another moment here to see if there are any further questions. And I'll let everybody know.
And my email. My email is grant@marigold.ab.ca. So if you want to get in touch with me, that would be the way to do it.
Perfect. This session is also being recorded, and it will be shared on the Marigold Library System's YouTube channel. But as soon as it's ready to go, I will email all the participants and let them know that it's there for viewing. Okay, we have a few people just saying thank you.
Oh, well, thank you for coming. This has been fun.
Okay, awesome. No further questions seem to be coming in. So again, sorry, Grant, what was your email address again?
It was Grant, Grant, at marigold.ab.ca.
Perfect. Okay, well, thank you so much, Grant.
Any coding question.
Thank you, everybody,
well, thank you
for joining us today, and I hope you enjoy the rest of your day.